Hi, for this video I would like to present about our topic, which is thermal comfort in train coach. First of all, I would like to present our team member for this project. So our aim and objective of this project is we introduce intake and exhaust system to maintain temperature inside the coach with a time interval. Then, to maintain comfortable temperature, the usage of inverter technology was needed. In Malaysia, traffic is one of the problem that led people in Malaysia to usage public transport more than use their own car, such as train, KTM or monorails. For your information, Kuala Lumpur, a city with population estimated of 1.76 million, has seen a rapid growth in public railway transit systems. So our team present the aim and our objective to access the facilities improvements inside the train by improving the thermal comfort design.
So I would like to ask you a question about how is it the temperature inside the coach during the peak hours and also during the non-peak hours?
Okay, I can say during peak hours it's probably a little bit warmer just because everybody's taking up the space, and then on top of that you sometimes got to stand up and get against the push and pull of the train itself.
Here's some video that we take when we do some survey at KTM UKM. After we go to KTM and do some survey, we had found the comparison with the current conditions. The air usually warmer inside the train during peak hour. The humidity is also high too. So we decide install inverter aircond because the outdoor compressor can slow down or speed up, while the compressor for non-inverter aircond that can only run at single speed. It also give more energy saving and cool room faster than non-inverter units. For your information, non-inverter aircond consume more energy because frequent start-stop operation. Why do we choose inverter aircond? This is because it can slow down and speed up the compressor to maintain the same level of cooling. Next, we develop an intake and exhaust ventilation with time travel. This system can overcome several diseases that can harm passengers that use this train. It also can bring fresh air and contaminated indoor air. Next, this is our problem statement. First, because of the exposed hot weather at waiting area, the passenger felt uncomfortable, so we want to create comfortable environment after they got into the train. Second, we want to have better air ventilation in the train coach so that we can reduce heat in coach at fast rate. Last, we want to make sure the temperature is suitable according to time and number of crowd. We want to improve temperature when peak hour and during night time. Here's some illustration of our main component after we had some discussion and some survey. This is our sketch for our design. This is how it's work. The first sketch is we introduced an air ventilation system to each of the train coach. The ventilation system will be switched on by a timer every time the train stops at a station. Right after the door of the train was closed, the system will be switched on for 1 or 2 minutes. Then clean air is introduced into the space. This air is either mixed with the air already present in the enclosure to give mixing ventilation, or is used to displace air in the space to give displacement ventilation. Next, the exhaust fumes at the back of the coach will suck out the bad air and release it back to outside environment. Ventilator at the back is positioned at the top because hot air is less dense than cold air. Thus it will be suck out, resulting a very comfortable cool surroundings inside the coach. Next, the plan is to change the original air conditioning system to a new one, which is the inverter AC. The biggest difference between inverter and non-inverter AC is the fact that the motor of the inverter compressor has a variable speed. The speed of the non-inverter compressor is fixed. This means that it operates either at full or minimum speed. A sensor in the inverter adjusts the power according to the temperature in a certain room, resulting in lower electrical consumption and save energy. The last one is our project plan. That's all for this short video presentation. Thank you for lending me your ear. Thanks for watching.